Welcome everybody. In this video we are going to continue our lecture on chapter 2. So last lecture we talked about the incremental and absolute coordinates, and we highlight how we can define these coordinates for the CNC milling machines, which has uh, three axes, which is X, Y and Z. Today we are going to talk about the CNC turning fundamentals and the Cartesian graph for the turning machines. And usually the lathe machine or the CNC turning machines has two axes, which is X axis and Z axis. X axis is represent the vertical axis, while the Z axis is represent the horizontal axis. So in this machine, when we want to use this machine and we need to define our coordinates to run or to operate these machines, we need to define the reference point or origin point, and usually our origin is x0 and z0. So this is the point, which is x0 and z0. The z-axis is equal to 0 and the x-axis is equal to 0, and we place our workpiece on this area, which is represented by the red area here. This represents our the workpiece, and usually the point of origin or the origin point here is placed on the center right hand end point of the workpiece. So this is the center. Actually, that means the distance from this point to this point is equal to the distance from this point to this point. So it's located at the center right hand of the workpiece. So if the red piece here is represent the workpiece, or the so it is on the right hand of this workpiece, and it is at its end point. That means it's not in the middle, it's not on the top, on the bottom. No, it's in the center and right hand of this workpiece. Usually we may use the end point, I mean the left hand endpoint, as our origin as well. So but the most common is to use it on the right hand endpoint of the workpiece. So this is to define the point of origin. After we define the point of origin or the reference point, we are going to define other Cartesian like we did in the in the milling machine, either based on absolute coordinates or incremental coordinates. So for this case here, we need to define, or we need to differentiate between two type of programming. One we call it diameter or diametrical programming. The other is radial programming. So the diametrical programming, it depends on the diameter of the cylinder. So if this the blow here, the blow area represent the workpiece that we want to to use, or either to drill, or to run on the lathe machine or on the turning machine. So the diameter of this point, if our program depends on the diameter, so that means we need to know what is the diameter of this workpiece from this point until this point on the x-axis. So because it is vertical, so it's related to the x-axis. So this we call it the diametrical or diameter programming. So when we define our coordinates, we need to make it based on the diameter or the total diameter of the workpiece around the z-axis here. This is the z-axis. So the z-axis is located at the center of this cylinder, for example. So we have here the full diameter is from this point of x, of positive x, until this point of the negative x. So for example, if the workpiece has a 5-inch diameter, if this area is positive or is equal to 5-inch, if the diameter of this area is 5-inch, from the out diameter here, the outside diameter, and we want to give the coordinate for our machines, so we are going to define x plus 5, for example, or x5. So this is x5.0 will be our command for, or in the program of the CNC turning machines. Okay, so because we are talking about the diameter, so our we want the machine to move for 5 based on the diameter of this cylinder. It will become x5. If the diameter is 10, it will be x10. Diameter is 2, so it will be x2, and so on. So it depends on the diameter of this cylinder, for example, or the diameter of this spherical shape, uh, we are going to define our coordinates accordingly. So what is the coordinate? Is it incremental or absolute? Later we are going to see how to define for both of these type of coordinates. The second type of programming here is related to the radial programming. So the radial program, which depends on the radius of this cylinder, or the radius of this circle of the cylinder here. So when we talk about the radius, we said this z-axis is located at the middle of this or at the center of this workpiece. So when we talk about the radial, that means the distance from here on this side, or the distance from here on this side. I mean the length of this radius, either in the x positive or in the x negative. So for example, if we have the full diameter is 5, so the radius will be 2.5, which is 5 over 2. So either in the positive x or in the negative x. So when we define this in our program, we are going to use x 2.5 as our coordinates along the x-axis from the central axis, which is the z-axis here. Here we are going to see how we can define the absolute coordinates, and later we will see the incremental coordinates. So the absolute coordinates here, in order to define the absolute coordinate for the CNC turning machines, and we see here we have for example, this is the shape that, or this is the workpiece. We usually use the half of the shape, the top half of the shape, because it is identical around the horizontal axis. That means even we have this drawing here on the top, it will be symmetrical on the bottom here also. It is the same, like this one, this one, this point. I mean, it is identical. So usually, to make it easier to write the program, we write the program for the upper half of the workpiece. Then that one will be like the mirror around this z-axis. So the values all will be identical around the z-axis. So for example, if we have, this is the top part of our workspace on, and this is the point of origin, which is x equal to 0 and z equal to 0. We want to see how we or how the coordinates for these different points, either at this point, at that point, here, this point, how we can define the coordinates for the machine in the program in order to allow the machine to move around these all points. So usually the machine, or the machine head, or the spindle here, will travel along the axis first. So we are moving, or the spindle here or the head will move along the z-axis, then until reach to the point that we want to define, it will up to the x-axis. Okay, so for example, if we are talking about the point P1, which is located here at this point, and this point is represented by -1 x and -2 y, for example, I mean z, for example, here. So usually the original point for the absolute, we have only one reference point, which is 0 and 0. So this is 0 point x and 0 point z. So from the 0 point here, the radial or the spindle here, I mean, will move along the z axis until reach to this point -2. I want to define the coordinates for the point P1, so I will stop here at -2, and then I go up on the x-axis until I reach to the value here, which is 1. Okay, so in this case I can define the value here for P1. For example, it is -2 for the first point, and for the x is positive what, or 1. Then I want this spindle to move to B2, for example, and B2 is here. So how to define B2? Usually we are going to move also along the z-axis. So from -2 until negative, because this point is at -3. This is the main point. So it will move until -3 on the z-axis. Then again it will go up until this point, which is +2 on the x-axis. So here, for example, it will be -3 z and +2 for x. So this is when we are using the absolute coordinate. Absolute coordinate, that means all points are measured with respect to the origin, at the point of origin, or to the 0 point. So here we have -3 to this point, here we have -2 to this point on the z-axis, and here we have +1 to the z-axis and +2 to the I mean to the origin, and +2 to the origin on the x-axis. Okay. So the first you need to move along the z-axis, then until you reach to the point below the point that you want to plot, then write down the z value and then go up until you reach to your point on the x-axis here. Okay, so write down the x value. You now have the x, z, or zx coordinate for this point, either for p1, p2. Try for other points here. Define this p3, p4, and so on. So then you can make a table for all these values. So in the case of absolute coordinate, is clear. I don't think there will be any confusing about this point, because we are going to measure the point location with respect to the point of origin. Usually our coordinates will be x and z. So the first value will be for x, the second value will be for z. If we are talking about the radial, so in the case of radial value here, we are focusing on the radius of this shape, or of this figure, workpiece. If we are talking about the diameter, so all these values will be multiplied by 2, because for the diameter will be the full diameter. That means if it has if the diameter is 5, so we are going to be the radial will be 2.5. If the diameter is 6, the radial will be 3, and so on. In the case of the incremental coordinate, as we said, this, if we assume this part represent only the top part of our figure, or the top part of the workpiece, and usually the workpiece is identical around them, because this point, origin point, is placed on the center. As we said here, it is on the center of the point. So here it's located on the center right hand endpoint. So this is the center. That means in these examples we are talking about these two parts only on the top, but we didn't consider the bottom part, because the bottom part already, by default, is there, since it is identical, and the workpiece is placed on the central of z here. So when we have this part here, so in the case of the incremental coordinate, the same. That means this part is just the top part, since it is our reference point is in the center of the right hand end. Okay, the right hand end here. So this is the center. That means we have also the same here, until to 1, then 2, then again 2. So it is identical, same like this one. Okay, this part will be the same. So when we write our program, we just write for the top part, and then it will be duplicated or mirrored for the second part. So we're talking about the point of origin. It's equals to 0z 0x here, 0x and 0z. So if we want to know for the what is the difference will be in the incremental case with the case of absolute here. In the incremental, we said our current point will be our reference for the next step. Okay, so the current position is our reference for the next position. The current coordinate will be the reference for the second coordinate, or the next coordinate. So usually for both absolute and incremental, the first reference point will be 0 0. Then after that we are going to change for incremental, but for the absolute we'll keep it 0 0. Okay, so for incremental here, if we want to know what is the coordinate of the different points here on this figure or on this drawing, we are going to also to move the spindle or head will be moved from the origin point to the first point. Then the first point becomes the reference for the second point, then move to the second point, become the reference for the third point, and so on. So as we can see here, if this is the point of origin and we want to find the coordinates for the point P1 here, so this is 0 0, and if the machine is directly moved to the point P1 here without passing through other points For example, we assume that we only want to define, this is our first point, we call it P1. So the first point here, P1, the spindle will move on along the Z axis negative here. The Z negative axis, it will be -2, correct? Until -2, it reach to the P1, so it will go up until reach to the +1. So the first point here will be -2 on the Z axis and +1 on the X axis. So it will be like 1. If we are talking about the radial here, we are not talking, I mean, we consider the radius only, not the diameter. If we want to consider the diameter, so it will become 2. Okay, so the Z here will become -2. When the machine or the spindle, I mean, reach to this point, now this point become our reference for P2. P1 become the reference for the P2. Now from B1 here, in order to reach P2, the spindle will move along until reach to the P2 here. So P2 is reach, I mean, it exists on the -3 of Z. But what is the distance between -2 until -3? It's only -1. Okay, so the distance is -1 towards the negative axis. So the Z value here become -1. Okay, because from -2 to -3 it's -1, and on the x-axis it will increase by 1 because it's incremental from +1 until 2. So this is the incremental here at this point P2, so it's equal to 1, so it will be +1. Okay, so we said this in the case we consider only the I mean in the incremental coordinate, and we only consider the radius of the figure or of the drawings. So in the case of using the diameter programming, so this become 2x2, this become also 2, same. Why 2? Because its diameter is equal to 2 times radius. So if the radius is 1 1, so the diameter will become 2 2. Okay, there are two exercises here. Please try to solve, to fill up the information about different point A, B, C, D, E, and you write it here in terms of the x-axis and in the z-axis using the two either the incremental coordinates in exercise 4 and absolute coordinates in exercise 3. See you in the next video.